Hi, I'm Paul Battaglia, and this is Section 5.1. Students come into Section 5.1 having integrated a wide variety of things, and they've even applied some of those concepts. But now it's time to go even further with some of those applied problems. Particularly in 5.1, we're going to take a look at differential equations. So the essential question we would like students to be able to answer at the end of Section 5.1 is, how do I find the solutions to differential equations? The great thing about Section 5.1 is it actually gives BC students something new to look at. So, for instance, they're going to see Euler's method. And this is really the first distinct topic that they've seen in the course that's really all theirs. And they can make it their own. And they like that. But let's get back to slope fields for a second. Slope fields are really a graphical solution to a differential equation. And that's a great thing to look at because there are some differential equations that we just can't solve by hand. So we need a picture to help us out. So here are things that I think we want to emphasize to students. When they're drawing the slope field, which can be tedious at times, what are things they need to worry about? Well, I tell them very simply, let's try and look at the steepness of our line segments. Let's look at whether or not those segments are positive or negative when they should be. Let's also look at the overall direction of those segments as it relates to the differential equation. Now, example 5 is a great one to look at because in example 5, we see that they also ask us to draw a solution curve through a specific point. And the reason I point that out is because on the AP exam, they may actually be asked to do this. And here's something that we have to watch out for. When I'm drawing a solution curve through a slope field, I want to do two things. Number one, I want to follow the correct field. And number two, I want to make sure I go through the point that I've been asked to go through. Now, that's the common mistake. Students sometimes do one and not the other. So just kind of point that out. Now, here's a great graphing calculator discovery for students. When we're dealing with slope fields, there are some patterns that actually come up. And if you can create a program in the slope field, or if you can maybe find a program somewhere and have students walk through it, might help them really see the connection. Let's suppose I give students a differential equation solely in terms of y. I'm looking for them to pick up on the pattern that all of the rows in the slope field are the same. And if I give them a differential equation in terms of x, all the columns in the slope field are the same. Okay, let's move on to Euler's method, a BC topic. So Euler's method is a numerical approach to approximating the solution to a differential equation. And it's interesting because some of my students in a BC class find two different methods helpful. On the one hand, some students actually like to use a table and go through the calculation that way. Myself, I find that cumbersome and really tedious. And I think it's a lot to remember, not just now, but months from now, when I might need to call it up. And then the other half of the class sometimes use just the analytical method, and that serves them well. So talk to your students. Ask them what works for them. I would actually try and direct them more towards the analytical way of doing things, but if they're comfortable, leave them be. Now, the other thing I think students want to be able to do is identify the correct differential equation when they're looking at a slope field. Now, what we've done is provided exercises 51 through 54, or exercise 90, a great AP exercise, where students are viewing a slope field and the question simply asks, which of the following would correctly represent the differential equation that goes along with this slope field? I hope you found these tips helpful. I'm sure you'll have much success in Section 5.1.